Okay, no more goofing around with setup or theory. It's time to start writing some real code. In the last section, we generated a new project using the React Native CLI. I'm now sitting inside of that project directory, the albums directory, and I'm going to open up my code editor inside of this folder. So we'll say atom dot. Notice if you don't have atom installed on your system, you might not be able to run that atom command. On the left-hand nav, I'll see a bunch of different files and folders that were automatically generated for us by the React Native CLI. Remember, this was all created by the react init command. Notice that there are immediately two folders, one named Android and one named iOS. By default, React Native assumes that you will want to run your project on both Android and iOS, so it sets up tooling to run on either platform. Right underneath those two, you'll find a folder named Node Modules. This houses a bunch of JavaScript dependencies for our project. So if you open up that folder right now, you'll see dozens of different folders, each of which is a separate dependency that is being loaded into our code base. Underneath these folders, you'll see a couple different files that are used for configuration. In general, we won't be really touching any of these different files. Then a little bit lower, down here towards the bottom, you'll find the file that we really want to care about for right now, which is the index.js file. This is the root file, the starting point, the entry point of our application. So when we go to build our app, we are going to start adding some code inside of this index.js file. If we open up that file right now, you'll see just a little bit of code inside of it. Again, this is all pre-generated by the React Native CLI. Now, I'm a big believer of understanding every last line of code that gets written. So the first thing that we're going to do here is highlight this code and delete it. So we're going to rewrite everything inside this file from scratch so we really understand what is going into building a React Native application. This looks good. Let's continue from here in the next video. In the last section, we explored our project structure a little bit and cleared out the contents of the index.js file. In this section, we're going to start with the absolute basics, which is to attempt to get some content on the screen of our mobile device. Whenever we want to place some content on the screen in any type of app we build, we are always going to do so by creating a component. A component is a widget of sorts. It's a thing that produces some text or a shape or an image that can be rendered onto the screen of our mobile device. The apps that you and I build are going to be composed by collections of these different components that we are going to make. So our job right now inside of this index.js file is to create a component and then somehow render it onto the screen of our mobile device. So to help us in this first task, we're going to add some comments to guide us along. So up on the first line here, I'm going to add one comment. I'm going to say the first thing we need to do is to import a library to help create a component. Then a little bit underneath that, I'm going to say that we are going to attempt to create a component. And then a little bit further underneath that, we're going to say that we are going to attempt to render that component, so render it to the device. So let's talk about these three steps here in a little bit greater detail. So the first thing we're going to attempt to do is to import a couple libraries to help us make a component. Components are intelligent objects that have a lot of inner workings associated with them. So we don't want to have to implement all that fancy pants code every time we make a component. So instead, we use a few functions provided by React Native to make the process of generating a new component much easier for us. The next thing that we're going to do is use that library that we just imported to create a new component. Now I keep using this term component over and over again. Remember, this is a thing, for a lack of a better term, that produces some content that's going to appear on our mobile device. Finally, the act of just creating a component doesn't actually do anything. We have to specifically tell React Native to take the component we just created and place it onto the screen. In all of the different apps that we are going to create in this course, we'll have to deal with a dozen or so different components. And at every step along the way, we always have to be very specific in telling our device exactly when to display each of these different components to our users. So let's begin with step one up here at the top. We're going to add a little bit of code to import two libraries into this file. So let's write it out. I'm going to say import React, import React from React, and import React Native from React-Native, like so. So already some crazy looking code, because all this time we've been talking about this library called React Native, but now it appears that we are importing two separate libraries here, one that's called React and the other that's called React Native. Let's take a short break right here, and then we'll figure out exactly what the difference is between these two libraries in the next section. In the last section, we started writing out our first component and hit an early stumbling block with just the first 2 lines of code here. We are referencing 2 separate libraries, and we're also doing so with this strange import syntax. In this video, we're going to discuss the differences between React and React Native, and we're also going to review the import syntax that we are using to pull a library into this file with. So I'm going to pull up a diagram, the first of many, many diagrams that we're going to be looking at, to figure out what the difference between the React and the React Native libraries are. When we work with a React Native application, we are interfacing with 2 separate, distinct libraries authored by the React team. React Native and React. Again, 2 separate libraries. Each has its own distinct job. The React library contains a bunch of code that describes how a component should behave, such as what functions it should have, and it also knows how to deal with a big pile of components, like how to take a bunch of components and make them work together. Like I said earlier, we're going to end up making apps with a dozen different components, and something needs to know how to take all these different things and make them work together. That is the job of the React library. On the other hand, React Native can be thought of as our portal to the mobile device, like the thing that we can use to get kind of a handle on the mobile device that we're running on. It knows how to take output from a component and make it appear on a mobile device. React Native also provides us with a couple of primitive components that we can use to show simple text or simple images. For right now, we're not going to sweat the differences between React and React Native too much. I'll be giving you a lot of direction on which one of these we're going to be using at any point in time. And soon you'll know which one to refer to like second nature. The next thing I want to talk about is a quick review of import statements. Import statements, like the 2 we have here, are a part of ES6. And you might recall that ES6 is a new version of JavaScript. With ES6 code that we write, each file can be thought of as having its own little separate apartment or cell. By default, no file gets access to any global variables or anything like that. Only by importing libraries into a file can we reach out to other files and work with code that exists elsewhere in our project. So with that in mind, the 2 import statements that we have right here start to make a little bit more sense. This file that we're working on has no access to intrinsically any variables within our project whatsoever. Any outside code that we want to work with inside this file must be imported, and so we added one import statement to import the React library and a second one to import the React Native library. Okay, so that is, I know, a lot of discussion for 2 simple lines of code. Let's continue in the next section and work on our next step, which will be to create our component. In the last section, we started working on our first React component. Remember, a component is something that produces some amount of text or content that we can render on the screen of our mobile device. We're going to continue working on this component in this section as well. As I said previously, I'm a big fan of understanding every single line of code that we put into our code editor. So as we continue through the course, we're going to have a lot of long discussions about every piece of code, just like we did in the last section. But as we cover each topic, we'll significantly speed up the pace. One of my favorite aspects of React is that the library has a tiny API. There's not a lot of ways to work with it. So once you learn those ways, you can make some pretty awesome apps without worrying about a whole bunch of complexity. Anyways, just a real quick aside. So step 2 on our 3-part journey of making our first component is to actually create the component itself. We've already imported some amount of code to help create it, and now we need to actually make the component. Remember, the component is an object that produces something that can be placed on the screen of our mobile device. So to define a component, we write out a JavaScript function. this function must return some object that describes what it should look like on our device. So we're going to write out our first component, and it's going to be a function. We're going to call this function app. Because we called it app right here, we will refer to it as the app component for our device. Next, we're going to add a little bit of code in here that is going to look a little strange, but we'll discuss its purpose immediately. Okay? So we'll write out return, and I'm going to place some parentheses. And then in between those two parentheses right here, we'll write what looks like HTML. I'm going to use what we refer to as the text tag. And then inside of that text tag, I'm going to place just the content some text right here. So let's now stop. Again, we're going to be writing a lot of just single lines of code and then talking about what they do. Let's talk about what is happening right here. So this bit of code tells React Native that we want to render some text to the screen of our device. But that's not the weird part here. The weird part is that this certainly looks like HTML that is being written inside of our JavaScript, right? We've got HTML looking tags right here. So you might be thinking, Stephen, why are we writing HTML in our JavaScript? Our mobile device isn't even rendering HTML. And that's totally correct. We are not writing HTML here. We are instead writing a dialect of JavaScript called JSX. JSX is an extension to the JavaScript language that is used to write React components. In practice, JSX follows the same semantics of HTML. We have opening and closing tags. So we have opening and closing. And the name of the text is used within a set of brackets. Finally, some content is placed between the opening and closing tag. When we place one tag inside of another, we refer to that as nesting. Or if we place some text within a tag, we also refer to this as nesting some content in here. We'll be using JSX throughout this course, as it is our one and only way to communicate with React Native about what we want our app to look like on the screen of the mobile device. So the last thing I want to mention here about JSX is that even though it looks like HTML, it is still JavaScript that we're writing. JSX exists only to make our lives easier as a developer. It's really just syntactic sugar to make our code a little bit more legible. To prove this to you, I'm going to open up my browser and I'm going to navigate to babel.js.io. Babel is a tool that takes JSX and turns it into normal JavaScript. So up at the top center here, and click on Try It Out, and this will take us to the Babel REPL. So if we place some amount of JSX on the left-hand side, it will turn it into raw JavaScript on the right-hand side. So on the left-hand side is the JSX that we might write inside of a component, and on the right-hand side is the compiled JavaScript that is actually what is being executed on our mobile device. Notice how, in this case, I've already got some amount of JSX on the screen. I have a single text tag, and within that, I've got several other text tags. And when this all gets converted into JSX, it turns into a series of calls to react.createElement. So this is like the big surprise here. JSX is really just a mask over normal function calls. As I said earlier, we use JSX just to make our lives easier. So even though you might think to yourself, well, why don't we just write a series of react.createElement calls? And the answer to that is that as we start to get more tags on the screen, as we add more tags to our component, it starts to turn it into a big nest of function calls. So the authors of the React library realized, well, nobody really wants to write a whole bunch of calls, of function calls to react.createElement. It's a lot easier to read a whole bunch of nested HTML, or what looks like HTML over here on the left-hand side. So that is the sole purpose of JSX, is just to make the code that we're working with appear a little bit more legible on the screen. Okay, so let's do a wrap up here. In this section, we wrote our first component. A component is a JavaScript function that returns some amount of JSX. In turn, JSX is a dialect of JavaScript that tells React Native what content we want to show on the screen. In this case, we created a text tag, and inside that text tag we placed just the string some text, which presumably is going to tell React Native to render just this text on the screen. So let's continue the next section and figure out how to render this component on our device, or how to make it appear on the screen of our device. In the last section, we created our first component, the app component. And I know I've said this 4 times, but I'm going to say it just one more time. A component is a JavaScript function that returns some amount of JSX. React Native is going to take our component and render it to the screen. When I say render it to the screen device, I mean it will run our component right here. It will take the JSX that gets returned, and it will decide, based on the JSX that's returned, what the content should appear on the screen. So if this was to run, and inside of React Native, I would expect us to see the text on the screen, some text. Just creating the component, however, doesn't actually do anything for us. We have to undergo step number 3 down here, which is to actually render it to our device. When we create a component with React Native, nothing magic happens. There's nothing to say, oh, they made a component right here. I recognize that. I'm just going to try to arbitrarily render it onto the screen. One of the very important lessons of React is to learn that nothing really gets wired up for you. You have to very purposefully tell React Native all the different ways that these different parts of our application fit together. And so this component is a fantastic example of that. We have to specifically tell React Native that we want it to take this component right here and render it to the screen of our device. So that's going to be step number 3. So for step number 3, we're going to write a little bit of code here to just tell React Native, hey, please take this component and show it on the screen of our device. So let's write out the code, and we'll discuss exactly what it's doing. I'll write React Native dot app registry dot register component, and I'm going to pass in a string of albums, and then this is going to be the really interesting part. As the second argument to this function, I'm going to place a fat arrow function, and I'm going to return app from it. Note that when I use a fat arrow function without placing any curly braces, there's an implicit return of app right here. So if we ran this function, it would automatically return app even though I don't have the actual return keyword in there. Okay, so let's talk about exactly what's happening here. In any React Native application that we create, we have to at least register one component to the application. And that's exactly what we're doing. We're saying, hey, React Native, you're about to render an application called albums. So the name of the string right here must match up with our project name. When we created our project using the React Native command line tool, we called it albums. And so therefore, as the first argument to this function, we pass the string albums. Second, we pass a function that returns the first component to render for our application. We only have one component right now, so we're just going to return the app component. Again, for every React Native component, or excuse me, for every React Native application we create, we must register at least one component. Okay, so this is pretty much it. This is all we need to get at least some amount of content on the screen. But before we run this in the simulator, there's one last thing I want to do. I want to do just a little bit of a refactor here. You'll notice that I am importing React Native up here, and I'm using React Native.appRegistry, which is okay. And I've also got seemingly an error about the text tag that we're using right here. When we look at the ESLint error, it says that text is not defined. So it looks like there's still a little bit of issue that we've got going on here. So let's resolve this error in the next section. In the last section, we finished up with step number 3, which was to make sure that our component would show up on the device. The last thing we must make sure that we resolve is that we handle the declaration of this variable text. So remember, the important thing here to remember about every single JavaScript file that we're going to create throughout this course is that there are no global variables that we can reference. There's no like magic code that is provided to us. So this text right here is an undefined variable, and if we executed this code, it would throw an error. We have to always make sure that every variable we reference is automatically defined for us. So this text tag right here is a primitive element that is provided to us by the React Native library. So to get access to be able to use this text tag, we must import it from the React Native library. To do so, we're going to use a technique called import destructuring. Okay, that's the name of this technique here. We're going to write out the code for it, and then we'll talk about exactly what it does. I'm going to delete React Native right there. I'm going to replace it with one opening and closing curly brace. And inside this, I'll write out just text. You'll notice that the instant I do that, the error message goes away from this line right here. So text is now defined. What this line means right here is it means to say, when you import the React Native library, I don't actually want access to the whole library. I just want access to the text property out of that library. So this really depends on pretty intricate or detailed knowledge of what different properties or objects the React Native library contains. And you'll learn about all the different objects that it contains over time. So this one that we've used right here so far is the text tag. Another library, or excuse me, another property in the library is one that we've already used down here, the app registry. So notice that when I replaced the React Native reference up here, all of a sudden now this is giving us an error message saying, well, now React Native isn't defined. So to solve this, we will also import the app registry function from React Native as well. So after text, we'll place a comma and then reference app registry. And then finally at the bottom, because we're not making reference to React Native anymore, I'm going to delete the React Native dot, like so. Cool, so now we've got, we are importing text and app registry from the React Native library. We are using the text tag inside of our component, and we are using the app registry component at the very bottom of our file here to render our component to the device. The last thing I want to do is you might notice that our component, we're getting a little bit of a complaint here from JSX about how it, well, the error message says unexpected block statements surrounding arrow body. So like I mentioned just a minute ago, if we are referencing just a single element, or excuse me, if we've got just a single return value from a fat arrow function, we can omit any return statement and the curly braces. And so that's what this error message here is about. ESLint is saying, hey, all you're doing with this fat arrow function is returning some variable or returning some object. So for stylistic concerns, I recommend you drop the return statement and you drop the curly braces as well. We're going to see this error message a lot throughout this course. It's totally up to you whether or not you want to do the refactor or not. This is not an error. It is really just something that ESLint is saying, your code would look a little bit better if you did it this way. So again, I leave it up to you whether or not you want to do this or not. Just to give you an example, the refactoring, I think I will go ahead and refactor it. So to get the error to go away, I would delete the curly brace up here. I would delete the return statement right here and put the parenthesis up on the line above it. I'll delete the curly brace at the bottom and then indent everything like so. So now I'm just left with const app, fat arrow function, and this will return this block of JSX right here. Again, totally up to you either way. I'll go both fashions throughout the course. Okay, so we've now got a full-blown React Native program ready to run. So if you recall, we spoke much earlier about how to run a React Native app in an earlier section, and the methodology is different depending on what platform you're on, either OS X or Windows. If you don't recall how to run the simulator with Windows, then you'll want to go back a couple videos and review that process. Otherwise, if you're using iOS, at the command line inside of our project directory, we will run React Native run iOS like so, and this will start up our iOS simulator and launch the app. Now I've already got the simulator running right here, so I'm just going to refresh it. And okay, this is our app now, as ugly as it looks. You'll notice that up on the very top left, I've got the text, some text. So it looks like it's up there, but it's definitely overriding the status bar. So this is, hey, like our content is showing up. It looks like our component is being rendered, but it definitely does not look very good at all. So let's figure out how to fix this in the next section. In the last section, we got our first component to show up on the screen of our device. So I'm using iOS on Mac right here, so I'm using the iPhone simulator. If you're on Windows and you're developing for Android, you'll see this in the Android simulator. And as you can see, you can kind of see that we've got the some text right there, but gee whiz, does it look pretty ugly. At least, though, we got some content to show up on the screen of our device, and we've got a better idea of what the import tags are, what a component is, and how we actually render it to the screen of our device. So We will fix this up in just a second, but before we do, let's talk a little bit about the first application that we're going to be building, and then we can come back and start to improve how this thing looks right here. So let's open up a mock-up of this first application that we'll be making. So this is the mock-up of our app. The app's purpose is going to be to display the user with a number of different music records that they can purchase. Like, when I say records, I mean like actual CDs. At the very top of the app will be a header that simply says albums, which is the name of our application. Then below the header will be our list of albums. Right here, I'm only showing a single one, but we should have support for showing many albums that the user can scroll through. Each album will be represented by this kind of big rectangle right here, which we'll refer to as a card. On the header of the card should be a icon of the artist, so like the singer or whoever created the record. It should display the album's name, the artist's name, all inside the header. Then in the body of the card, which is this big X right here, this represents the album image, so like the actual album artwork. It should be a nice, very large image right in the center of the card. Finally, at the very bottom of the card should be a button that says Buy Now. And whenever a user clicks this, we should direct the user over to a page where they can purchase the album. So we're not going to be building that actual purchase page. We're just going to kick the user over to an Amazon.com page inside their browser on the device where they can buy that album if they want to. So again, we're going to have many different cards. Like, and a card is this whole unit right here is what I'm trying to say. And we'll have one unit or one card for each album that we've retrieved or fetched. Okay, so this is basically the application that we're building. It's going to be our first one, and we're going to focus a lot on just the basics of React and how we use React Native to build an application like this. At the start of each app that we build, we're also going to spend some amount of time to plan out exactly how we're going to tackle that project. In particular, we're going to decide what different types of components we want to make. As a reminder, a component is a function that returns some amount of JSX. And JSX is what tells React Native what content we want to show on the screen. Whenever we build a React application, we attempt to make components that are generally as reusable as possible, so we can write one component and then use it in several different locations throughout our app. It's all about reuse of code. For this application, we're going to make several different components to build this application. Here's kind of a diagram of all the different components and what they might be called. We might make one component called the header component that will just sit at the very top of our application. Then, to represent a single album, we might make a card component. So a card component has many card sections inside of it. And each card section will have some amount of content. So the one at the very top will be the actual album, artist image with the name of the artist and the album name. And then another card section that shows the image. And then another card section that shows the Buy Now button. In addition, we might even make another component just to represent the Buy Now button. We'll talk more about all the different considerations of when we want to make a reusable component versus when we want to make like a very kind of one-off or custom component as we work throughout this application. So planning out our components ahead of time like this just makes it easier later on to have a very solid idea of kind of the different parts of the application that we need to focus on when we're building it. Gives us kind of like, it just makes it easier to build the application when we know what we want to make ahead of time. Okay, so honestly, this is a pretty ambitious app to start off with, but I'm confident that we're going to be able to work through it and learn just a ton about React Native along the way. So let's get started with it in the next section. So now we've got a better idea of the application that we're about to build. Let's get started working on it. I think the best place to start is going to be working on this header component right here. Remember, we organize our React applications into a series of different components. So we're going to make a single component called the header component, whose sole purpose is going to be to sit at the top of the application and show the text albums. Now we've already figured out how to show text in React Native, so chances are the biggest challenge here is going to be figuring out how to style it nicely. How to make the text nice and big, how to center it, and how to make a nice header all around it. So that's going to be our big challenge here. So let's get started. In a React Native application, we always create one component per file. So one component per file. Inside of my index.ios.js file, I've already got a single component located in here. So to create a new component, I will make a new JavaScript file to house it. That means that for the larger our application gets, the more components we make, the more files we're going to be working with at one time, which is totally fine. It's something that you're going to get used to. To create my new component and the new file that goes along with it, I'm going to place it inside of a new directory in my project folder. So in my project folder, I'm going to create a new folder called SRC. And the thought here is that I'm going to place all of the code that I write from my application inside of this SRC file. It just helps, or excuse me, folder. It just helps create division or kind of separate from all the boilerplate that got generated with React Native versus the code that specifically we write and we intend to be used with our application. Secondly, inside of this SRC folder, I want to make another folder called components. So I'll make another folder called components. And this is where I'm going to make all the different components that we're going to use inside of our application. As we start making more complex applications, we'll have other folders inside this SRC one that have radically different jobs. And so that's why I like to make this second one just to say, hey, specifically in here, this is where all my components go. And that's pretty much it. Okay, so now inside of here, last step, we'll make a new file to house our header component. So I'll make a new file called header.js. So this is it. This is where we're going to make our header component. And the purpose of this header component is to just show a nice rectangle with some text inside of it that says albums. That's it. That's all we're trying to accomplish here. So to get started, we'll kick off with the same 3 steps that we used inside of index.ios.js. First, we will import libraries for making a component. Then we will make a component. Finally, we will make the component available to other parts of the app. Notice here that I changed the comment a little bit, right? Whereas in the index file I said rendered on the screen of the device. This time around I'm saying, well, I don't really want to immediately render it to the screen of the device. I just want other parts of the application to be able to use this component and reference it. And so we'll figure out exactly what I mean by that when we get to step number 3 here. So let's start off with step number 1 at the very top. We will import some libraries for making a component. And we're going to import the same 2 that we did last time. We're going to import React and React Native. So we'll import React from React, and then we'll import React Native from React Native. There we go. And notice that ESLint is immediately unhappy with this because, hey, we're not actually referencing these variables here. That's totally fine. We'll make use of them in just a moment. So step number 2, we need to create our component. As a rule of thumb, when we create the component, we will always name it a function that is the same as the file that it's placed in. So we're inside of header.js. Therefore, we're going to create a component called header. And we'll make our component, which is a fat arrow function. And then from here, we're going to return some amount of JSX to render. And you'll notice that this time I'm not going to use the parentheses right away. That's totally fine. I'm going to, again, kind of vary through styles throughout the entire course on exactly how this looks. It's really up to you. There's not a super solid convention. Well, actually, I take that back. The convention is throughout the community, whenever you've got a single line of JSX, you just put the return statement on the same line. If you have a multi-line statement of JSX, that's when you'll start to use the parentheses. So, I've got kind of obviously a little bit of foresight on exactly how many lines of JSX we're going to make. So throughout the course, I'm going to seemingly randomly either use parentheses and put everything on a new line, or sometimes I won't. But we'll see. So we got the text tag here, and then inside the text tag, we'll place some amount of text to show to the user. So I'm just going to say albums, hooray. Now immediately I'm using a text tag right here. So I'm going to pull the text tag out of the React Native library. So I'm going to delete React Native at the top, and we're going to do a destructured import to import the text component. And immediately all those errors go away, and we're left with just, hey, text albums. Cool. Finally, on to step 3 here. We need to make sure this component is available to other areas of the application. So this is where things start to get a little bit of interesting. Back inside the index file, we registered this component using the app registry, but I'm saying that this time around inside the header, I want to do things a little bit differently. So let's figure out exactly why that is by looking at a diagram really quick. So this is a diagram of our component hierarchy, or all the different components we have in our application. As I've mentioned several times before, a normal React application will have many different components created for it. Each one a reusable widget that we can make use of in several different locations. So when we join all these components together, they form a tree of sorts, where the very first component to be rendered to the screen is what we refer to as the root component. So right now, because the first component that gets rendered to the screen is the app component, we refer to it as the root component. So the app is the root component. Then every other component that the app one shows is referred to as a child component. So pretty soon we're going to tell the app component to show the header one, so we'll refer to the header as a child component. So coming back around to this whole concept of all these import and export statements and the app registry, all that kind of stuff, well, basically I got the text on here. Only the root component uses app registry. That's the only time we use the app registry, is for the most top level, most parent component. It's the component that we want to show first on the device. And it's up to that app component to decide everything that needs to be displayed to the user. For every other component that we create, so for every child component that we create in our application, instead of registering it with that app registry, we export it using ES6 syntax. So just as we have used import statements at the very top of our file, we will also use export statements at the bottom. Export statements you can kind of think of as meaning, hey, I want to make this component, the header component, usable to other areas of our application as well. That's the whole idea behind this export statement. So at the bottom, we will write export default header. So again, this means take that component. I want other files within our project to be able to make use of it. So let's now continue in the next section and figure out how to make use of an exported component. In the last section, we created our header component, which currently just shows some text to the user. We then ended the section by using an export statement down at the bottom. The header component structure that you see, the import statement, the declaration of the component, and then the export statement at the bottom, is going to be super common, 100% reproducible, and we're going to use it all over the place for all of our different components. So you're going to get very used to seeing this type of structure inside of our component files right here. Continuing this section, we're going to figure out how to make use of a component that we have exported. So again, export statement means we can now use this inside of other files inside of our application. As I've said several times before, we use multiple components together to create more elaborate applications. To do so, we make use of a practice referred to as component nesting. Component nesting is the process of placing one component inside of another. So these two topics, component nesting and consuming exported objects, really go hand in hand. To get more experience with this, we're going to import the header into the app component, so inside of this index file, and then we're going to nest it inside of the app component. And when I say it, I mean we're going to nest the header inside the app component. So this is going to be a two-step process. First, we're going to import the header, and then we're going to nest it inside the app. So let's do step 1 first. Underneath the two existing import statements, we'll add a third import to import the header. So we'll say import header from, and now this last statement, this string over here, is going to be a little bit different than the ones we've written previously. Previously, we wrote just React or React Native to say, hey, I want this specific library. But that only works when it's a file that we write, or excuse me, when it's a file that we installed with npm. If it's a file that we have written ourselves, we have to provide a relative path reference to that file. So by relative path reference, I mean we need to imagine that we're sitting inside of this albums folder right now, and I need to make a reference to the header file. To do so, I'll say /, which means start in the current directory, so in the albums directory, then go into the source directory, so src, then go into the components directory, and then get at header. If it's a JS file that we're making reference to, we do not have to put on the .js at the end. We can just place just header by itself. So now I'll go ahead and save this, and boom, that's all we have to do to import a file. I want to draw your attention back to the big difference between these import statements we've written so far. Again, if it's an import statement that is for a library that was installed as a NPM module, which is the case with both React and React Native, then we can just write the name of the module. But if it's a module that we write ourselves, we have to provide the path reference for this. So let me tell you a little bit about why that's the case, because that always annoyed the heck out of me. With NPM, all module names or all package names are always unique. So we have no uniqueness, or excuse me, we can never make two modules called React. And so when we put just a name of the library, our packager assumes, oh, hey, they must be making reference to a NPM module. I'm going to go through the node modules directory and try to find a folder called React. And when it finds it, great, that's what this library must be here. But in the case of files that we write, well, we might have many different files in our application called header. We could have one inside the components directory. We could also have a file called header inside of the src directory as well. And so if we just said import header from header, well, the packager would have no idea which header we wanted. It might be the one in the source directory, or it might be the one in the components directory. It just wouldn't know. And so that's why for files that we write, we have to specifically say where that file is. Throughout the entire course, I'll make sure to give you a lot of help on whether or not we're using a relative path or just a library name. And in addition, for every relative path that we use, I will certainly make sure to give you a lot of help on exactly what that path is. Okay, so that's step one here. We have imported the header component, and now we're on to step two. We have to nest the header component inside of the app. So to render one component inside of another, just treat the imported component like another JSX tag. So I'm going to delete the text tag that we've got right here, and I'm going to replace it with the header. So we'll say just header. Now by convention, if we have a self-closing tag, or excuse me, if we have a tag that does not have any text that goes inside of it, as is the case with this header, I don't intend to place any text inside of here, we turn it into a self-closing tag. And that's what the ESLint rule here is complaining about. It's saying empty components are self-closing. So to make a self-closing component, we'll delete the second tag and then place a / and a closing bracket. So now we get just header by itself, and that's all we have to do. Now notice that when I do this, we are no longer using the text tag up top, right? We're not using the text inside this component, so we can delete the text import now. And we're left with just the header by itself. So this right here, again, is referred to as component nesting, when we take one component and place it inside of another. It's our chief tool for making really complex applications full of a lot of different components. The last thing I want to do is test this out inside of the simulator. So I'll bring the simulator up and I'll refresh it by hitting Command R. If you are on Windows and you're using the Android simulator, you can hit Control R instead to get to refresh. So now you'll notice that, well, the text is still overlapping on the header up here, but now you can kind of tell that it says albums instead of the some text that we had before. So it's still ugly, but at least we got the text to work. That means that the header component is correctly being displayed within the app. So this is great. Well, let's continue in the next section and fix up the header with some styling so that it looks nice and centered at the very top of our application.